Okay, this question is about whether I should have a pool test or not a pool test. That's it. Correct. So how to decide whether to have a pool blood test? So there are two situations. So actually X. Okay. The answer that I give, I put 1X, 1Y. Okay. So up to you. So I can put my X as a binomial distribution. Okay. And the N is 100. And the probability P, they say, it can assume that the probability that this person will have an Ebola virus. So P is the probability that a person will get Ebola virus. So you have to put a note there. P is the probability what? That this person, or you can say a person, okay? A person will have a Ebola virus. This happened in Africa, Ebola virus. Okay, so for part A, X is a binomial distribution. The N is equal to 100, and the probability that a person will get the Ebola virus is 0.01. So for this one, there are two cases. One is whether to have a pool test, pool blood test. How am I going to decide whether to have a pool blood test or not? That means the probability, that means all the people is negative. Everyone is negative. Okay, negative means probability of X equal to 0. No one have the Ebola virus. So you go for a pool. If it's positive, then you go for 101 test. Everyone have to test. All right? So that means everyone is, if one, at least one. So you will have 101 tests if probability of X more than or equal to 1. At least one person positive. So that is how you decide. So that's why for the A part 1, right, the probability will be X equal to 0. I put X equal to 100 because I'm using all 100 is negative. You see, I put the probability at 0.99. So this one, you can use your binom PDF. All right, you put 100, 0.01, and here put 0. You get the same answer as mine. Okay, then for part 2, the probability will be whereby he said, hence, what is the probability if a pool blood test is used, the pool sample will be positive. Pool sample will be positive. So this is pool blood test. This is negative. This is positive. So positive will be X greater than or equal to 1. So this one is 1 minus, actually you can put 1 minus the answer from part 1. It's the same thing. Hello? Are you clear? So then for part 3, right? For part 3, you just have to follow what the formula gives you. For part 3, you just have to give the expected value is 1 time of answer from part 1 plus 101 times of, because you only have one test. answer from part 2. That's it. Then you get the expected value. Okay? Are you okay?
Yep.
Yeah, so far. Okay, so let's go to the part C. Yeah, you have the part C with you. The part, okay, hold on. I'm at the wrong page. Yeah, so the part C, they say, give a reason. Give a reason why pool blood test is preferable on testing individual sample in this case. So you see, because the expected value to do the test is only what? What is the value? You look at the answer, the value is only from this case, the value from this case is only 64. Or you can say 65. You only need to do 64 or 65 tests. Correct. So that's why it's less than the expected value. Less than, instead of test all the 100. So that's why part 4, you say answer from part 3 is less than 100. Got it? So that is how you go. Okay. Then after that for part B, show that in a large town. So now you change the P. Then they ask you, now for part B, is a binomial distribution, n equal to 100. But in this town, the probability of a person get the virus is very, very high. It's 0.075. Correct or not? Then they say, pool blood test is not preferable to test individual sample. Okay, the reason is because for this one, the probability of having a negative is very, very low, almost 0. So actually, it all go to positive, correct? So that's why the expected value is higher than 100. You understand the meaning of part B? So part B, you do part 1. B, you have to do part 1, that is probability x equal to 0. You count. Then part 2, you repeat part A. You repeat part A. So probability of x greater than or equal to 1 is approximately 1. So that means part 3, the expected test that you need to do will be 0 plus 101 times 1. So is equal to 101, which is more than 100. So that's why it's not preferable. Are you okay? Okay. So now we go to part C. So for part C, your x is also a binomial distribution. X, n equal to 0, p equal to p. Okay, so now you want to know the expected value, you follow this formula. Okay, 1 time probability of x equal to 0 plus 101 time probability of x greater than or equal to 1. So this will be probability of x equal to 0 plus 101. Probability of x greater than 1 will be 1 minus probability of x is equal to 0, correct? So this will be probability of x equal to 0. I expand it plus 101, take away 101 times probability of x equal to 0. So this one minus this one. So I got 101, take away 100 times by probability of x equal to 0. So this one, I apply my formula. 100, n is 100, C0, p to the power of 0, 1 minus p to the power of 100 minus 0. So I got the formula. This is 1. This is 1. I just follow the formula. I cut short. My answer there, I cut short. Okay? Are you okay? Rush, you can understand? Huh? Rush not here today.
I'm still processing.
You are following this formula. You are following the formula given in part A3. Part A3, isn't it? They give you the expected number equal to 1 times of, where is it? Okay, 1 times of what? Yeah, 1 time of 1 test needed. The 1 test needed means the whole thing is negative. You only need to do 1 test. So the probability of 1 test. 1 test means all are negative. So you need to do 1 test only. Plus, if at least 1 is positive, then you have to do the 1 plus all the 100 you have to do. That's why you have to have 101 times by probability of 101 test is needed. Okay, you want me to go back to this one? I'm talking about this part. The part 2 is you need the probability of negative. If it's negative, then you have to do 101 test. What is the probability of positive? Means out of the 100, at least 1 is have the virus. Negative means all don't have the virus in the group of 100. So I'm talking about if the chances of a person getting the virus is this, so what is the probability that none of them got virus? So this is called the probability of none of them got the virus. So that is called negative. So how to do a pool blood test? So if everyone is negative, if at least 1 is positive, then that is called positive. Positive, then you have to do 101 test. So that means if I do like that, I put a test, number of tests. This is 1. Probability is whatever I get from part 1. Then 101 test. So the probability I get from part 2. So my expected number of tests will be what you call part 3. You get me? So this is the probability distribution table for this situation. So I have only 2 possible, whether do 1 test or 101 test. Can or not? This question is quite difficult to understand what exactly the question wants. That's why they put in last. Usually they are very kind one. They won't put the difficult question at the beginning one. Okay, that means in the group of 100, I don't have to test the 100. If I go by this, I only need to test about 64. Expected number of tests. If I do a pool blood test, depend on your outcome. That is a situation. So how they select all that one is, there is more on detail on the statistics side already. That one, those who study all this research, they have other criteria to talk about. No need, you don't have to include this in the table. I purposely draw this table to help you to explain. To tell you what is the meaning of the part 3 and how the formula come about. Okay, can or not? This is for here. Okay, can I move on?
Yes.
Rush, are you okay?
Yeah, I just need to read through again on my own time to fully understand.
So that is how how my formula come about from here. Okay. This is a negative. This is a positive. Okay, can or not? Yeah. So can I move on to 2016? Okay, which question you want me to explain?
Question 4. I'm not so sure I understand the answer because the graphs in all regions seem to be negative. So how can the answer you get be positive?
Okay. Question 4.
Yep.
Okay, you all got the part.
For part C.
Part C. Okay, never mind. We start from part 1. Okay.
Right.
Just explain the whole thing. So the function given fx is equal to x over x plus minus 4. So we know that the domain. So please, I don't know. I just keep talking about the domain. I don't know. I have that kind of feeling. So x is a member of real number, and because it's a rational, the bottom x minus 4 cannot be 0. Correct? So x cannot be 4. So the vertical asymptote is x equal to 4. Right? So that's why the graph, you have x equal to 4. Okay, so now we want to talk about the function. So you see, I'm going to study a little bit about the limit because I see the past 2 years, they didn't come up with the limit things. I don't know, maybe it will. So as x approaches infinity, so what happened to my fx? Fx approaches what? Okay. Anyone? So
0.
okay. So let me reshuffle fx and let you have a look at it. Can I write my fx as 1 over 1 minus 4 over x? Is it okay?
No.
Why not? Why not? Everything divided by x, can or not? Can or not?
Yeah.
So you can do like that. That will help you to see much better. So what happened to 4 over x? Will approach
Zero.
0. So what happened to my fx, which is 1 over 1 minus 4 over x? Will approach? Hello. Huh? Your
1.
graduation say, yeah, will approach 1. Say, you didn't answer me, but you are listening. So will approach 1 from above. That means this is the lower limit. Am I right? Because of the minus sign here. So that's why you have another horizontal asymptote. Y equal to 1. So from here, horizontal asymptote. Y equal to 1. Okay? Are you okay? So now, okay, as x approaches negative infinity, actually the graph will go like that, right? And you see the graph, we also can study like that. As x approaches 4 from the right. From the right here, you go from here. So we want to know what happened. As x approaches 4 from the right, that means the value of x is more than 4. Like, give you an example. Okay, example, x equal to 4.0001. So you think what happened to fx? Definitely, it will approach, divide by very, very small, correct? So you will approach infinity, am I right?
Uh-huh.
So the reason is because x minus 4 will approach 0. So therefore, fx will approach infinity. So that's why the graph go infinity. So if I see the fx approaches from here. Okay, if x approaches 4 from the left, from the left means my x is less than 4. So for example, your x equal to 3.999999. So your x minus 4 will approach 0. Approach 0, you also can be, but it's a negative value, correct? This is a positive value. So therefore, your fx will approach negative infinity. So this is something about the vertical asymptote that I'm worried that they may ask. Okay, this is very crucial because it will determine your A+ or A. Yeah, can or not? Okay, so I'm just explaining this part of it. Okay, so then from this value of, for what value of x is fx decreasing? You look at the graph. all the graph is going down, am I right? Hello? When we talk about the graph, you go from left to right. So for this one, it will be the domain. Am I right? You just write down this value. So X is member or real number, and X cannot be 4. That means for all value of X, Fx is less, F prime X is less than 0. Yeah. So this implies that Fx is decreasing. That means F prime X is less than 0. Fx is decreasing, imply F prime X is less than 0. So, yep. So that is the implication that I have. So straight away I know already. Okay. So now they say part 1, find the average rate of change. You see, I told you already, average rate of change. That means slope of the chord. So do I need to do that part for you?
No.
No, 5 to 7. So 5 is here. 7 is around here. So you draw the chord. So on the graph, draw a representation of your answer. That's why I say for the first principle, you have to understand the slope of a chord is the average rate of change. Are you okay? Okay. So for part 3, see, what is the problem of your, so the first principle, you know how to do, Hello?
Yes, but the answer you gave is positive. I'm not so sure how you got that. We just established that F prime X will be less than 0 for all regions of the graph.
So my answer can be wrong, Hello, young man. So my working is wrong. Possible?
It's possible.
Possible. I told you already, it's possible for me to make error. Okay, so I got, where is my error? Can you find my error? Where is my error? Can someone detect my error? Minus 3h. You see or not? It's supposed to be minus 2h. 6 plus h take away 6 minus 3h. So the answer should be negative 2h. So there is an error there. My expansion that time I make an error there. So, but never mind lah, at least I explained this part to you. Okay? So it should be negative 1. Am I right?
Yes, negative 1.
Should be negative 1. So please, there is an error. Human can make error, okay? Okay, anything else? No more. That's all, is it? Okay, if that's all, can you go to 2021 Northern Hemisphere Booklet 1? Anyone got problem with question 1? You have problem with question 1? Okay, if you don't have a question with question 1, I would like to ask you. To 2021 question 1, part B. Can anyone tell me why the question have to why? Why? Can you explain why? Why the question have to put for x greater than 0?
Is it because negative doesn't exist in ln domain?
Yes, because when you integrate this, you got 8x minus ln x plus c because of this. Because when you integrate 1 over x, you get ln x. Okay. Now, okay, so this, from this question, it triggered me to think of a question if I ask you to integrate from 5 to 7 ln x dx. How are you going to do this? How are you going to do this? You don't think that they won't ask, huh? How are you going to do this? Anyone have any idea? Okay, we have 2 ways of doing it. I'm going to illustrate it from the graph. Five is here. 7 is here, correct? I want this area. Yeah. This is y equal to ln x. Yep. So I ask you, is it possible for me to find this area? Is it possible for me to find that area? May I know what is the y value for this point A? X is 5, y is
1.6.
ln 5, huh?
1.6.
Yeah.
Ln 5 lah.
Yeah. B, x is 7, y is ln 7, correct? So if I want to find the red area, I have to integrate ln 5 to ln 7 dy, correct? I told you already, the limit must be y and dy. So I have to write my x in terms of y. Am I right? Hello? Can or not? So, can I integrate this? That is equal to what? 2. So now you tell me how to get the blue area. Look at the diagram and tell me how to get the blue area.
Find the area of wait, this minus the red area and minus
The very big rectangle, that is 7, ln 7. Take away the small rectangle, 5 ln 5. Then take away the red area. Am I right? Hello? So you will get what? What will you get? 7 ln 7 minus 5 ln 5 minus 2. That's it. Right? You can do it like that. In your textbook, there is also a question look like that. Do you know that? How the question look like? In your textbook? Your textbook, the question look like this. The question, part A. Given fx equal to x ln x. Find dy dx. Then part B. Hence, find the exact value of or not? Got such a question in your textbook? Go and search. That's why I say, look at your textbook. What do you want me to say? Oh, because we can't integrate ln, and exponential is the inverse of ln. Understand that? When I go to ln, so I can yeah. So how I get the 2? Because I know that e to the power of ln anything is the number itself. Do you write down this one? So this one, when I substitute, isn't it e ln 7 minus e ln 5? So you see, you have to master a lot of things. Okay? You don't have the formula with you. Okay, so this is one of the questions in your textbook. So when I get the dy dx, okay, so I use products rule, right? One times ln x plus x times 1 over x. So I got ln x plus 1. Are you okay? So therefore, when I integrate ln x plus 1, dx, I get x ln x. So when I integrate ln x dx, I get x ln x minus integrate 1 dx. So this will be x ln x minus x. So now I put in the limit. I tell you, you want to get A, you must be as versatile as me. It's not too much. I'm not too demanding. I'm telling you, I'm not too demanding. That is what you are supposed to. Isn't it exactly what we have? Sienna? It's up to them how they want to come up with the question. I told you they modify a lot of questions from your textbook. Okay, so textbook, people have spent so much time writing the textbook. All the basic concept there is there. So reading textbook is very important. Very, very important, especially for maths, I tell you. You want to do well in your final, you please go through, especially some of the special questions in your textbook. Are you okay? Any further question? Okay, which question you want me to help?
Sure, can go to 2014 paper.
2014 paper. Okay. 2014 paper. Which question?
15.
I don't think I can explain that in such a short time now. I will do it in the next class. Can or not? Question 15.
Yeah, sure.
What's wrong with that question? I just want to know.
Actually,
is
when I
the
look at the first question itself, I already got confused because like the graph looks so small, but then they said more than half. You know,
Okay, because question 15, question 15, not 17. Okay, 14. Okay. Which part? Question 15, which part of question 15? The part A.
that is one of the issues, but I prefer if you can discuss the whole question.
Okay, so you want me to discuss the whole question? Next lesson, you are who are you? Rush. Who is that?
Yeah, major.
Rush. Okay, so I will discuss. Okay, so for both class, so Rush, you are in group 2, correct? Okay, so I will discuss so. That question. Yeah, tomorrow 1 o'clock class. Okay, so everyone 2014 question 15. Okay, the other class I will do it afterward. Okay. Why, Rush, you have problem with the statistic question, is it?
No, I just want to understand all the theory questions. So if they change the values, I can still answer in the exam.
Yeah, you are right. So that is the way. You don't just get the answer, that's it. Okay, good. That is good. You want to understand further what is the basic required so that when they change the question, you can answer. Yes, that is the right attitude. Okay, the rest, still doing your other subject? And okay, I stopped the recording.